Hello, everyone. This is Alex USA Days, and we're continuing with our journey learn quality assurance from scratch. So now we're moving into a new module. Today we're going to talk about types of testing, but it also has a little bit about test plans. And with the last video, we actually completed the section on development methodologies. Okay, so there are about 100 different types of testing, even more than that. There's a lot. You don't have to remember all of them. You just need to be aware that they exist. We will talk about the main tests, main types of tests that perform during QA. It is really hard to cover in a short video everything, so I will provide links in the description to this video where you can read more about what kind of tests there are, what kind of tests exist. One will be to the Guru 99, the other will be to Atlassian website. Essentially, you will probably maybe use like 5, 6, 7 different types. What kind of tests what kind of types you will be running will greatly depend on the application you will be testing, customer, the end user, who it's designed for, by whom, and so on. So there are really a lot of variations. What kind of product you're testing, what kind of tests you will be running. But on the highest level, I think you can break it up into those categories. So you can have black box, white box, or gray box testing, where black box you provide input and then you get some output back. You verify this output. And you have no knowledge of the system. So black box term actually comes from programming, where it means exactly the same thing. You receive some sort of a system that you need to work with, but you have no clue how it works inside. You can't really look in the code. So black box testing is mostly like manual testing without access to the code. Then there's white box testing, and with white box testing, you do actually have access to the code. You know what's going on inside. You know the functions that are running, and maybe you even work in the same repository alongside with developers. Maybe you're doing some automation. So it involves a good extent of coding knowledge, understanding the code base of the application, what it's doing. And then there's a gray box testing where you maybe have some access to code at some place, at other places not. It's a mix of both, or maybe you're just testing something in between, so you don't really know what's going on the back end, but you do work with API. So gray box testing is essentially like mix of both when you're testing front end, back end, looking at the code or not looking at the code. So it's a mix of everything. Then you can break up all the tests in positive, negative tests, where positive tests they're also called happy pass tests. So you verify what user is supposed to do. So if user needs to log in or they provide proper login and password, they log in. If the user needs to create new account, they have to have certain complexity for the password, certain lengths, maybe certain symbols are not accepted. Negative testing is actually acting like a user that doesn't really know what he's doing and trying to kind of break the application or see what happens if you provide some invalid input, do some unexpected actions from the user, and see how the application handles it. So in our example of invalid login, like we had valid as a happy pass, and valid login, you try to provide an invalid password and verify that the actual error comes up. Or when you try to create an account in the password, you start typing out invalid characters when you're trying to create new passwords. So it also should gracefully handle it and show some errors to the user. Then there's functional and non-functional testing. So those also include a lot of different tests, different categories within them. But functional testing is the testing where you test against the requirements, and it is an acceptance criteria based testing. So you want to look at the actual functionality of application, what's supposed to do. It includes unit testing, regression, integration, user acceptance, localization. We'll talk about those types of tests later. And then there's non-functional testing, where verification of the system is more about the stability and performance. So it's including stress testing, performance testing, load testing, security testing, and so on. Okay, so this is like the highest level. Now we're going to talk about categories that are more popular, and you most likely going to see them almost in any company you work. Maybe a little bit less of those or more, but this is very close to like having everything that you're going to encounter throughout your career. Some of the things might not be here now, or you might work for some industry or startup that has some specific testing. So I definitely recommend going into the description for this video and checking out the links to other types of testing just to get familiar with them, so you understand there are more other possible test type that exist. Okay, one of the most common types of testing that you're going to see almost everywhere is acceptance testing. So acceptance testing is essentially verifying feature or features and that they are implemented according to business requirements. You might also have heard about user acceptance testing. So this is essentially the same thing. You have a story that been in works, developers finish it, you do some verification of the story, and then you're okay to be released. It's acting as described in the acceptance criteria. Then there's regression testing. Regression testing, there are kind of two definitions. Some of the regression testing specifically evolves or revolves around bugs that you verify that nothing got broken after a bug fix. But I think in more recent ways, regression testing is like standard for rerunning through a set of scenarios after a bug fix, deployment, or release. If you're automating regression testing, those collection will be like the largest collection. So you'll have regression testing based on the priority, where you first will verify P0 test case, P0 being in like most important, then will be P1, P2, and P3. So regression tests, you essentially keeps on growing. You keep on adding testing there, making sure that you're covering most or all of the functionality that you want to verify once the application is released. If something gets outdated, your regression testing will get updated and some of the tests will get removed. But this is one of the most typical tests that you will be running, regression testing. Then there is API testing. Not all of the companies do API testing, or they do it in unlimited way. Some companies may be more API focused. So if you work as a manual engineer, maybe you'll not be touching API testing. But if you're looking to get into automation and grow, I think starting with API testing after manual testing is one of the great ways to kind of begin working in that direction. So API testing is mostly verification of communication between front end and back end nowadays, but also essentially API stands for application programming interface, and it is a middleware that allows different programs to communicate to one another. So there's a layer communication, there's a communication protocol, and there's a layer application between front end, back end, or two different apps that will allow them to talk to one another. Okay, this is API testing. This is actually testing that part. Then there's exploratory testing, and exploratory testing is verification that relies on testers' bug discovery approach around application functionality. So you as a tester with some experience, you look at the new application and you start testing a little bit outside of your normal testing process, not your normal regression or acceptance testing, but actually try to navigate yourself around the application, see what things you can break, how you can interact with them differently. That would be exploratory testing. It is mostly based on the tester's experience. Then there's boundary testing. Boundary testing is also quite common, and this is verification of boundary values. For example, verification of accepted age. So a good example would be, for example, you can use some piece of machinery or some application only when you reach 21, but you cannot use it if you're older than 100 years old, right? So your lower boundary will be 21 is positive test, still accepted input. 20 negative should not be accepted. This is your lower boundary for the acceptance, for the boundary testing, right? So if you can use it start at 21, on the lower boundary, you test 21 positive scenario, 20 negative. On the upper boundary, your positive scenario would be 100, and your negative scenario would be 101. So 100 should still be accepted, 101 should not be accepted. You can also throw in maybe a scenario in the middle. So let's say 50 is the 50 still going through. But typically you'd see lower boundary positive, negative, upper boundary, positive, negative. There's also something called smoke testing. Sometimes it's called sanity testing. Sometimes they're different. Every place will talk a little bit differently about what smoke is or sanity testing for them. What I've so through my careers, sanity testing is mostly just some developers having some build, they making sure that it still works properly before you handle it to QA. So like a very, very initial verification. Is my build still is my app still launching, kind of a thing, right? Smoke testing is preliminary testing that where you verify major functionality of the application and that it works as expected. So you would load, you would log in, you would, I don't know if you're using some specific application, let's say YouTube app, you can post a video, leave a like, and stuff like that. Uh, Essentially, your smoke testing enables everything else. If smoke testing passes, that means all other types of tests you can run those, you can schedule those, you can do whatever. But if smoke testing fails, means there's something wrong. The build has to go back, right? So smoke testing is required to enable all other testing processes, right? You don't want to start scheduling everything until you know that your build is pretty much stable. Then there is a type of testing called beta testing, and beta testing is early version verification in production environments. So the environment that actual users will be using on those servers and so on. There are two types of beta testing. There's closed beta, which is will have like limited number of users, and there's public beta that is going to be open to all. Beta is close to release application. It's very close to actually ready application, but it's not there yet. So the idea of the beta testing that you will have people try and test your system to find any extra issues or unexpected things before the big release. And if you're into gaming and you play games like I do, I play a ton of different games. There are a lot of beta testing. And you actually have to pay sometimes for it. So you would buy, not in terms of paying for the testing, but you would buy a game early release or early package for the game, pay a good amount of money. So also you can get a chance to participate in beta. So you can play the game a lot earlier than it's actually going to be released. Okay. Another common type of testing is stress testing, and stress testing is verification of stability, reliability, and performance of application under heavy loads and prolonged periods of time. So one example of stress testing would be, hey, what if I have this YouTube application and I'm trying to have millions or billions of users launch it at the same time on different laptops, right, machines and phones, and then or there's a video that I'm gonna try and play like for hours and hours, maybe 48 hours or 72 hours, and see how it behaves, right? Depends what we're testing here. Is it the app? Is it the system? Is it actually the phone? But stress testing essentially is structured around stability, reliability, and performance of application, and seeing the limit. How far can you push it to break it, right? This is stress testing. How long you can run tests, stress in the application. Then there's some more. So there's load testing. It's kind of close to stress testing, but load testing is measuring how a system will manage and perform under heavy load volumes over time within expected limits. So your goal is not to crash an application here, not to break it, but just to make sure that it handles the load properly, like it's doing what it's supposed to do. And if your website should handle 1,000 requests at a time, it should handle 1,000 requests. It should not decrease the performance, or the response time will only increase in a certain allowed amount of time. So it's not going to be 3 or like 5 minutes to load a page, maybe a couple of seconds, right? Then there's accessibility testing, and accessibility testing is verification of inclusiveness of application for as many people as possible. So it includes speech recognition, reading assistant, special inputs, and so on. You can read a little bit more if you're interested in that specific testing about the accessibility. You can read the Web Content Accessibility Guidelines. And essentially, this is kind of very focused on specific type of testing. There are certain tests like accessibility and localization where you can have a dedicated QA doing just that, right? Focusing on those specific features. Then there's localization, and it is verification of usability, accessibility, and content translation for a specific language region. So not only that it's translated properly, but it also makes sense. There's some maybe phrases that are common for the region and the overall application. So it's going to be different localization testing, for example, Spain. If you're trying to move application from England and create your branch in Spain, and then it's going to be different localization testing for Spain versus localization testing for Mexico because the Spanish there is different, right? And there's different variations, different things, like a lot of things that specific to that region have to be verified. And there are also QA positions that just do that localization testing. Then there's security testing, and security testing is a search for system vulnerabilities and exploits so they can be fixed early. For example, penetration testing that use different tools to find weaknesses and imitate attacks. So there are tons of different tools to perform different types of security testing. And now actually you have a very specific branch of profession called cybersecurity specialists that do a lot of that. A lot of security testing falls under cybersecurity, and cybersecurity is actually designed to prevent infiltration, data leaks, and cyber attacks, where QA security is more into finding issues during development if there are security issues. And there are two other types of testing that you're going to hear a lot about, and they're very common, but they're not exactly QA type of tests. There is dev testing, where they do unit testing. Unit testing is verification on functional level, like the smallest functions possible that should be created by developers alongside development effort. So if you know, for example, that password field only accept letters and numbers and not special characters, a unit test that a developer might write alongside of the creating that function for the password input that he'll try to pass along special characters, and the test should return some sort of meaningful error saying that they're not allowed. This is unit testing, so they create the tests around functions like on atomic, very small scale, right? And there's integration testing. Integration testing when you have multiple functions, multiple modules, maybe multiple microservices that talk to one another. So developers would actually build tests that will trigger other services or other responses where you verify multiple modules or functions combined and you verify them as a group. So, it's not just A plus B equals C. You also do some other functionalities with C later on involving other modules and your testing becomes more complex. But you need to do integration testing because you need to understand that all of the components of the system are working properly. This could be integration testing on a functionality level. This can be also integration testing on hardware software level when you try, putting your processor in different motherboards. So you kind of already like on a system level now as a whole thing. So yeah, that's in a nutshell. I'll probably pick a couple tests specifically from this list that we're going to talk a little bit more about, and I'll have additional slides, ones that you will see almost all the time. And then from that, we will move into test plans, right? What they are and how you work with them, how you get them, how they're created. And yeah, that's pretty much it. This section is not going to be very long, but I definitely recommend you go into the description, and I have a couple links there to show more types of testing. Just read them, get familiar with them. You don't need to remember them. The tests that I list here, those definitely you want to research more, take notes. So like this whole list, because those are the types of tests you're going to be running most likely one or the other out of that list when you join a company, right? Those are very common. The rest, just get familiar with them. They're in the link is in the description, so you are aware that they exist. Okay, so this was Alex USA Days. Hopefully you liked the video. Leave a like and subscribe. Leave a comment if you want to talk about something. And you'll see more of those videos on how to become QA tester from scratch, from manual, and then maybe some automation as well. I'll keep on posting like every weekend, add more content. Okay, thanks everyone for watching, and bye bye.